So I have started the recording. This is our lecture lab Zoom for Design 350. We're doing it a little bit later than normal because we wanted to get inside before it got too hot, which it's getting pretty hot. We're going to go over the calculations of the instrument height from the backside reading, which we've just looked at, but we'll go over it again. And we'll draw using the azimuth and distance measurement system. So here's what we did was we went out and we set up 3 different tripods, 1, 2, and 3, and each person took a rod reading. Okay, so that's a sighting level to the rod, and the rod was at an elevation of 0, 0. Okay, it's our back sight reading. It's our project 0. So we looked back to our project 0 so that we could figure out how high our instrument is. And in this case, we all took a bunch of readings and we took the average, and I spelled height wrong, height of the instrument. And since the rod was sitting on 0, 0, 0, whatever the rod reading is, that's the height of your instrument. Okay, because it shoots out level, sees the rod, and that rod is reading down to the ground. So shoot out level, hit the rod down to the ground. Okay, and look, that's really, really good. And these are in feet, decimal feet. So the height of the instrument is the rod reading back to 0, 0. And we're going to change that later on to make it more complex. But as you're getting used to it, that's what it always is. So that's 3/16 of an inch. The next one, we were off by a little bit more and a little bit more. But what we were working on was seeing if we could all read the instrument the same. And we did pretty well. We really got pretty close all the way across the board. Next week, you'll get lots and lots of practice on how to read those numbers that you're seeing in the scope. Okay? But for now, you can just know if you take a rod reading back to a 0 elevation rod, then that's your instrument height. Okay? And the ground elevation is always your instrument height minus whatever you read on the rod. That's the actual elevation of the ground where you put the rod. Yes, I will. I'm even going to type it. Okay. Elevation of a survey point is okay, so when you're taking a survey of a point, they put the rod on the ground. The elevation of the ground right there is the height of the instrument minus the rod reading. And so you can imagine why you need to get the height of the instrument right, or everything you do from there on is wrong. Don't put pressure on yourself. Okay, so actual elevation of a survey point, you put the rod on the ground, and the elevation is your instrument height minus whatever you read the rod at that point. And that's survey. That's all there is to survey. Now, it's not always easy to get those numbers. And the whole rest of the class is about, okay, what happens when it's not easy to get those numbers? Okay, cool. You see why we don't need any code? Right? So Zabihulu is asking, okay, well, you know, in all the other classes, we talk about ANSI standards and, you know, ISO standards and building code standards. What are the standards? It's just math. It's totally just math. The only time standards come into play is in how precise and how well you take your numbers. And we're not going to do that because we're going to struggle just to take numbers, right? I just need you to take numbers. And then if you get working for an architect that does this a lot, they'll teach you all the ins and outs. But if you've never seen a piece of equipment, never set up a tripod, they're going to go, oh, this is too much work. But if you go, no, it's like, oh, okay, remember, you got to put it down solid. You got to tamp it down. You got, they'll tell you all the tricks, right? And they'll be happy. Okay. So it's just simple. It's not even math. Literally, it's just drawing. It's like, oh, I get it. From here to here, I need to know the distance. So you can do it with math. It's addition and subtraction. I don't call that math. I call math sort of like, that weird train leaving New York and train leaving Chicago, and they're both going at two different speeds. Where are they going to hit each other? And you say they won't. They're on different tracks. So math is really, really easy for me because I'll just redefine the problem to make it easy. That's what I learned in engineering, by the way. So anyway, okay, there we go. So that was our first thing to do. Calculate the instrument height from a backsight reading. Well, since our backsight was at 0, it's the rod reading. That's your instrument height. So now let's take a look at drawing azimuth, angles, and distances. So what you're going to see, let me see if there it is. What you see here is how stuff looks. Let me see if I can put my annotate on. So this is a real typical, that was supposed to be on spotlight. There we go. That's supposed to go away. Okay, there it goes. It goes away. Okay, so when you take just in the worst spot. When you take these readings, you're going to see elevations over here, but I've left them off for now on most of these. But you see how far away you are from the rod and this weird thing called azimuth angle. That's when you're twisting the theodolite, and inside there, it's going to give you an angle reading. So as you twist it around, it's going to say, now you're pointing at this angle. Now you're pointing at this angle. Now you're pointing at this angle. So you're going to read an angle, and that's what you record. You record a distance and an angle. Remember, on Tuesday, we did a horizontal distance and a vertical distance, and that's called Cartesian coordinates. Now we're going to do polar coordinates. We're going to draw a distance at an angle. Okay, so here's my data. I'm going to move it out of the way so I can still see it. And I'm going to open up AutoCAD. Okay, well, the first thing I need to do is make a new drawing from my civil template. So let me go find it. It's not there. And then, you know me, I like to have a light background. And you just got to do this all the time. Doesn't take too long. You'll get good at it. And then I think I have too many bars down here. I don't have all the bars I want. Oh, look at that. I can put it over there. And so I'll make it so that I can adjust all these ones that you see here. And then the other thing I'm going to do, I'm going to make sure that my units for my line weights and lines are in inches. Did I start the recording? Yes, good. And there's one other thing I'm going to do. I'm going to go to my units. And I'm going to make sure I'm in decimal feet. Decimal feet, because that's what it said everything is in. I'm in decimal feet. Now, the last thing is you need to know AutoCAD likes to draw angles going counterclockwise. That's what it likes. These machines, angles go clockwise. So if I want to read this data and draw it, I have to click this clockwise button that's in my drawing units. Then my angles will go the right way. I hope. I hope they were the right way when somebody developed these numbers. So let's see. Let's see if I can draw one. Here we are. I'm going to do distance at an angle. And I'm starting from 0, 0 again. Start from 0, 0. And it's going clockwise. That's good. And I'm going to go, how long? 84.646. And I just type it in. And then I do tab, and it's asking for an angle. And I'm going to type it in exactly like I see there. 38D, 45 minutes, 56 seconds. There's my first point. Now my next one starts at 0, 0, and it goes 228.239. Tab. Gets me off in my direction. Notice I've got my dynamic on. If that's not on, the inputs are a little bit different than what you're seeing. But 13D, 25 minutes, 39 seconds. My next one goes from 0, 0 for a distance of 299.475 feet. I don't have to type anything in because it's already feet. At an angle, 42 degrees, 9 minutes, 28 seconds. I'm going to tell you more about all those later on. And then 211.559, tab, 71 degrees, 49 minutes, 19 seconds. And then I can put in my C prop. Yeah, minutes are an apostrophe, seconds are quotes. So that's kind of, and there we go, I've got it. That's it. Go to my B-size template, all the same stuff. And I need to get this at a normal-ish one. Got to go one more. There we go. And that would do it. Okie doke. So that's how you draw with those. Yes. Well, no, it's according to your reference. Okay, we haven't set the reference yet. I'll show you how to do that. Azimuth angle is your angle in the horizontal plane. If you want to choose north as your reference, then it's from north. If you choose to now, don't get you're getting way too hung up. You're missing the point. Azimuth is the angle in the horizontal plane. Okay, so the question is, what is the azimuth? So azimuth is the angle in the horizontal plane. Now, where do you choose to count 0 from? You can count from north, you can count from south. You can set up 2 points and say, that's my line that gives me 0. Okay, so don't get too hung up on little picky things that are actually only meaningful if you're working with those picky things. Okay, so it's hard, right? Because we always talk, oh, north is this way, north is that way. Now, and you'll have to find out, we'll get to that. Okay, but right now, where is 0 on AutoCAD? East. Yeah, 0 degrees is east or horizontal X to the right. So we haven't set where it is in the real world yet. So we're going to get it as east. Horizontal X to the right. Okay. Or east. So let's see what that looks like. That's a good question. See up here? See that east marker? When you go to the, when you see your nav cube, that's the standard AutoCAD setup. Now, your survey may not use that. That's where we're going to teach you how to align things, but that's in week 4, right? Right now, we're just going to take AutoCAD and go, let me punch in these numbers and it'll be fine. Okay. All right. So there you go. That's what you're going to, and there's 6 of them to do, right? If I go open a new one and go find that. Oh, good question. Where do I find the template? There it is right there. Resources page. Really? Is my, oh, don't tell me that when they redid our computers, they emptied it out again. That would be a bummer. Nope, there it is. Instructor files, design 350. So when you find me, design 350. And there's the civil template. Phew. You're looking for a DWG, change it to a DWT. There we go. Thank you. Hot dang. There. Yeah. So what I gave you is what's called a template file. That if you make a new drawing from the template file, it just imports everything into your new drawing. Layouts, layers, line types, so it's all in there for you. Yay, good, we found that one. Okay, so that's where we're at. That's how to use drawing with an azimuth and a distance. And the reason we're learning to draw with those is that's what you get from these. Okay, now if you're using a nice complicated laser system, you can choose to get XY like we did on Tuesday, or this. Okay, but we're going to make sure that we know how to draw like the information we get out of this. So the goal for, let's see what the goal for this week is in the modules. Set and level tripod. Alman noted that I did not have it set to accept image files. I've changed that so you can upload image files now. So this should be 3 image files. Okay, of your bullseye. We did 3 different tripods, so we should have 3 of those. On the next one, 3 images of your rough theodolite setups. That's the little picture of the bullseye on the theodolite on 3 different tripods. And 3 images of your spirit level. So now look, one thing that some people are not aware of is that you can upload more than 1 file. So you can, there you go. Now I can do 3 image files. So like there's one, there's another image, oops. And I'm not doing very well with my mouse right here. 2 and 3. So I can get 3 of them all at once. Okay, now if you do one and then do another and then do another, it's okay. I can see all 3. I can see all of your submittals. Sometimes I think students can only see one of them. Okay, don't worry about it. If you submit 3 different times, I'll be able to see them all. Okay. Yes.
Could you like measure your accuracy?
Okay, so you'll need to have, so you need to have your dynamics set. So that's why I did that. So over here, and dynamic. So that's why I go through all that stuff, change all those things every time. So they're set up. Now your dynamic is on. So go ahead and draw a line.
Yeah, I click on it and it's not giving me what you're looking at.
Why did you put it?
This one, right?
Yeah.
Oh, okay, so now type a
Okay,
distance.
so that's literally this.
Now hit tab. Tab.
That one, right? That's one we're working on.
Why
That's like you're choosing. I'm like lost.
Oh, okay.
I'm lost too, and I like her.
Okay, so type units. There it is. Got it.
Change it.
Cool.
This field.
Open it today.
Yes, decimal feet.
Seriously, okay, I can't find. I don't know what's happening. Is this what we're supposed to be opening for coordinates?
Yes, that's a whole bunch of PDFs. Oh, hold on a
It's a
sec,
Google
hold on a sec, no. Uh,
Both of these are the same exact thing right now. They both take me to this. I have the set of PDFs for the coordinate point files.
yeah, I had it wrong, but now it's right, so is that a copy? Did you make a copy of it? Okay, so
Yeah, it's
go back and make a new copy of it,
Okay,
because
okay.
I did have that mistake.
Okay.
And somebody pointed out, and then I fixed it.
okay, that's how it's like.
There we go. Cool.
Or you
It's
still
showing the
didn't
white screen, but for some reason it's not.
so you still didn't take it
Getting
with
me to like the. Should be able to draw this one. Change it to white. Just keep it in the dark.
That's interesting. I guess in dynamic that's really odd. That's a new thing in dynamic. So go below the line. So just drop below the line and type it in. So they made a change to dynamic.
it doesn't matter. It's a,
Well, you want it going this way. So see how if you drop below the line, it goes clockwise. And above the line, it goes counterclockwise. It's really weird. So the other way you can do it is take that off. And just type it in. So you can do it either way. Okay. So if your dynamic is on, it's catching, now I see it's catching above or below the line. But if your dynamic is off, then you have to type 6. But look, you see it, right? Get it right. This is like that's not. It's not too hard to get it right, and you're seeing what's going on. So just do it.
it doesn't matter which side.
Need the angles to be going clockwise, because that's what's on the sheet. Get it right, make it go clockwise. Yeah, you see it, right? If you can see it's wrong, you can see it's right. Make it so. Like Picard. Yeah, you can leave it like that. Yes, leave the survey lines on and don't worry about line type scale. Cool.
I can't for the life of me remember how you change the background.
Okay, right click in the middle of the background. Options. Display. There it is, and then colors. Yep. Yep.
Here.
That's all okay. Just go there.
Then where do we change the
Just type units.
units? Okay.
Yep.
Enter.
Yep. So that goes to decimal feet. Yep. And that goes to clockwise.
Thank you very much.
Okay. Leave student view. Okay, so let's go through again and just look really quickly. What's due are your images, images, images. That's set up in level tripod, 3 images. Mountain level, the theodolite, 3 images. And mount and fine level, the theodolite. Oh, I didn't go over tracing. You guys all know how to trace? Or should I go over that one? I'll go over it. That's a good idea. Good choice. Okay, so what you're supposed to do on the tracing one is get an image of a county. Here it is. Trace one of these counties below. All right, I can do that. So first I have to find an image of the county. So I do that with Google Maps. And I type in a county name. I'll do Yolo County. And I don't care about scale or anything like that. And that didn't give me my, there it is. And you can see it's kind of outlined in red. So I can take a snip of that. Come on, little snip tool. Control C and drop that into AutoCAD. So let me start a new one. So that's new, browse templates, go find my template again. Go back to my model space and I'll just do a right click, paste from clipboard. There, got it. And literally now I'm going to I'm just going to trace, but there's a few things I like to do. I'll click on the image, right click, and go to properties. And I like to change the transparency, maybe 70% transparent. And see how now I can really trace over it. And I'll do these on CProp. And I'll make it just regular lines. Now I don't need to be too careful or too close. See, I'm just kind of getting something. It's just a real quick visual. There we go. I've got Yolo County. Isn't that cool? Now what I might do is also take this and put it on a layer. And I just did that all on the wrong. No, that's okay. That's on survey marker. I might want to put that on the depth points layer so that it won't plot. Okay, so I can leave it looking like that, but then when I plot, since my image is on the depth points layer, it won't show up. And maybe I'll do a little bit extra work, DT, middle center, height 0.25, YOLO. There we go. Let's see how it looks. Oh, dang. Looks really good. Okay, so hopefully that one takes you just a few minutes. That's more than, and don't worry again, like I said about the line type or anything like that. I just want to see that you've got a good tracing going. Okay, and you can take a snip of it and save your file, and you've got it. Okay, so that was, there's your tracing. And what's due this week is draw by coordinates. But I'd like you to sort of get ahead a little bit if you can, and your progress check. Okay, so, and I'm not even sure if I asked you to put it, here's your point coordinates. Oh, here's one thing I wanted to bring up on the point coordinates. So you see how I kind of broke it into 9 lines for you, or 9 little boxes for you? Well, there's only 6 of these. So I did that so that you can sort of decide how you want to present this and if there's any information that you want to add. So you might want to put them sort of in a pattern like that. Okay, so you can use any number of patterns, and that gives you a little bit of place where you can add a little bit more information. You might add something like an image of your units. That didn't work. Okay, so it allows you to do just a little bit more as you work on it. Okay, so, or you can leave them blank and maybe put some explanatory text there, or even just leave them blank. And bearings are the same as azimuth, so you can change that. And did I ever give you an update so that you can do 1.6? I did. So if you need to get a slide for 1.6, you can add that in from, you can go back to the original, make a copy, and go put it into your copy. Cool. Okay. Cool. Any other questions as we're going through? Okay, Olivia, do you have any questions for me after all that? Oh, okay. You can type in if you don't have your mic, you can type into the chat if you have a question. We basically just got through everything, pretty much everything we needed to see. So I'll go ahead and stop the recording.